I'm going to look at solving quadratic equations, quadratic equation application problems. And just in one in particular, we're going to look at an example where we look at an object that is fired from the ground. You'll also see these like in physics classes and things, but an object is fired from the ground so that its height h in feet t seconds after being fired is given by h of t is equal to negative 16t squared plus 64t. So the leading coefficient is a negative 16. Essentially, it's like a quadratic. It's a parabola. It's an upside down parabola. So you think of this thing. I always like to kind of draw these out. Think of this scenario like this. We're shooting this object from the ground in this case. Sometimes we start out higher, but we're from the ground, shooting it up in the air, and it's landing back on the ground. I can ask you questions like, how long will it take before it lands back on the ground? Well, when it lands back on the ground, the height is 0, so you just have to replace h with 0. I may ask you how long will it take the object, or how long will it take the object to be a certain amount of feet in the air, like say 16 feet in the air. So we could try that one too. Maybe I'll make that problem up. Let's add another part to this one. Let's add part B. How long does it take for the object to reach 16? There you go. So let's try that and see if we can get an answer for that one as well. So the first one, though, I'm asking how long does it take the object to land back on the ground? Well, when I'm back on the ground, I'm just plugging in 0 for my height, it's my overall height. So I'm just going to say 0 is equal to negative 16t squared plus 64t. Now, I always think factoring first. Factoring is usually the easiest way to solve quadratic equations if they factor nicely. If they don't spend too much time. Use either the quadratic formula or completing the square given this, the problem itself. I'm looking at this and I'm going, okay, I'm going to try factoring. I can factor out negative 16 out of each of these. Or think of just, if you like them in positive, sending them over to the other side. So you really have this. 16t squared minus 64t is equal to 0. You want your leading coefficient positive by just adding up and subtracting that to both sides. Now factor out GCF. Always look for a GCF first of 16. And a t actually comes out of that too. And I'm left with just a t minus, what do we have here, 4 I think? 4 times, 16 is 64 equals 0. Cool, now I could take this problem and you have it factored, two things multiplied, set each factor equal to 0, 16t equals 0, t minus 4 equals 0. So t equals 0 and t equals 4. But I'm actually asking you, how long does it take the object to land back on the ground? So I know when I started out, I was started out on the ground, I was fired from the ground, so that was when the time was 0. So I can ignore that answer. I'm looking for when does it land back on the ground. So it would land back on the ground after 4 seconds. And I can also ask questions just like I asked down here in part B. How long does it take for the object to reach 16 feet? Well, I can have a possibility of 2 answers, right? Because 16 feet, say that's the height, it would go above 16 feet but then drop down in its descent, right? So when we're shooting an object. So let's try that. Let's plug in 16 for my height and see what we get. So we'll say 16 is equal to negative 16t squared plus 64t. I'm going to get everything on one side. I'm going to have 16t squared minus 64t plus 16 is equal to 0. I'm going to factor out then a 16. I'll be left with t squared minus, what do we have here? Is that going to work? 4t plus 1. That is not going to factor, but that's okay. It does not matter. So I'm looking at this and I'm like, oh man, okay, I have this. I pull out a GCF. I'm going to divide this out. I end up getting this. Shoot, this thing does not factor. Well, we know how to solve these things now. Quadratics, even if they don't factor, you plug them into, say, the quadratic formula. And so you take this, you identify this as t squared minus 4t plus 1 equals 0. and you identify your A as 1, your B is -4, and your C is 1. And go ahead and type that into your formula, and I would give an approximation. I would probably ask round to your nearest tenth of a foot on an application problem like this instead of giving me in the simplified radical form. So go ahead and try and plug that in and see what you get for the answers. I'm going to try it with my calculator actually. And I will show you with the calculator so you can actually just see how we could actually do this with the technology as well, just if we're trying to find an approximate answer. I'm just going to type all this in my quadratic formula. So I'm going to use a parentheses. I'm going to say -b, or like b is -4, so 4. I'll just do the plus for now, it's plus and minus. And then I'm going to say -b plus or minus, or plus the square root of b squared. So I'm going to go to square root b squared, which is going to be 16 squared b, right? Minus 4 times a, which is 1, I believe. Yep, and c, which is 1. So you could write the 1. And then I'm going to close this off and then divide it by 2a. So divided by 2 times 1. And when you hit enter, you should get an approximation of 3.73. Let's round it to 3.7 seconds. Now let's try the minus, and oftentimes you just end up throwing it away because it would be the negative. So actually it's not going to be well in this case. So there's one answer is going to be 3.7. Also, t is going to equal, I'm just going to do second entry, minus it should be at 0.3 seconds, approximately, for going here spent. So after 0.3 seconds, it will end up being 16 feet in the air, and then after 3.7 seconds, it will be 16 feet in the air. And that is how we can do that. I just entered in the quadratic formula and simplified it just using my calculator. Now sometimes your calculator will have the quadratic formula. If you have a graphic calculator, you can actually get the program for this, and that works great too. And these are for application problems when we're looking for a round. And that's it.